Welcome back to Mathematics Lifeline. Today, I'd like to go over the quotient rule and how to use it when you're solving a derivative. Now, the quotient rule is one of the major rules when solving derivatives. There's, the product rule, the quotient rule, the chain rule, the power rule. There's all these different rules, but the quotient rule is really important because you cannot solve certain derivatives without it. Just like all the other rules, there's some that you just can't solve without it. So right here, we're gonna go over this rule just using this function. So what this is saying is we have two functions here. So we have a bottom function and a top function. So what the quotient rule is going to do is it's going to take the bottom function as is, multiply it by the derivative of the top function, and then subtract that from this top function times the derivative of the bottom, all over the bottom squared. So I know that's kind of a lot to think about right now, but let's go ahead and set it up and you'll see what I'm talking about. So, right here, we have the first part is the bottom function. So the bottom function right here is just 4x squared. So we're just going to leave that alone. We're going to multiply that by the derivative of the top. And using the power rule, we know that the derivative of 3x is just going to be 3. So that's that first parenthesis right here. Now we're going to subtract the top function times the derivative of the bottom. So the top function is 3x. Times the derivative of the bottom. Using the power rule, we know that that's just going to be an 8x. And this is all over the bottom square. So we have 4x squared and then squared. So now, like with the product rule, this is technically the right answer. But there's a lot of ways that we can simplify this, so I think we should go ahead and do that. So we're going to go ahead and multiply these together. So we have 4x squared times 3. That's just going to be a 12x squared. Minus, multiply 3x times 8x. That's going to go ahead and give us 24x squared. All over this bottom function right here. So the bottom function is 4x squared squared. So when we square something like that, we have to square everything inside. So we're going to square the 4 and we're going to square the x squared. So when we square the 4, we're going to get 16. When we square the x squared, we're going to get x to the 4th. Now sometimes you're not going to have to multiply those out. You're not going to have to square it every time because there's a lot of times where this can't simplify at all. This is a case where we can simplify it, so we're going to do it as much as we can. So now we have a 12x squared minus a 24x squared. This is just going to be a negative 12x squared on the top over 16x to the 4th. Now what we can do is we can go ahead and factor out some common terms here. So the way that I like to do this is see what we can take out of the top and the bottom. So we know we can take out an x squared from both because we have an x squared and an x to the 4th. And then we can also simplify these coefficients. So negative 12 over 16, well, both of those we can take out a positive 4. So what we're going to do is take out a 4 and an x squared from both of them. So we have negative, right, and then we have 4x squared times whatever's left on the inside. So we just have a 3 over here. Over, we're going to take out a 4x squared from the bottom times whatever's left. So we have 4x squared in the bottom because we know that when we do that, it's going to go ahead and just multiply together. We have 4x squared times 4x squared. Now what we can do is go ahead and take these out. And we're left with our answer because we can't simplify this at all. So we have a negative 3 over 4x squared. That right there is going to be our derivative of this function. So, there's going to be a lot of times where you're going to be able to cancel some stuff out, you're going to be able to factor things. It's just going to make your answer a lot prettier than just this really broad, drawn-out answer. So we don't want that all the time. So let me go ahead and do another example. I have a video on my channel about some basic derivatives that you need to know, and I'll link to that in the description, and I'll put a card up on the screen right now. But we talked about, we needed to know the derivative of tangent x. And we know from that video that that is secant squared of x. And I told you that when we get to the quotient rule, we're going to be able to actually solve this other than just memorizing it. So let's go ahead and do that. So let's go ahead and find the derivative of tangent of x. So we're going to keep this secant squared x in mind up here. Secant squared of x. We're looking for that at the end. So remember from trig that tangent x is the same as sine x over cosine of x. So we're going to go ahead and write that down. So we have that. So we want to find the derivative of sine x over cosine x. Well, this is now a quotient. It's not just the tangent x. We now are dividing sine x and cosine x. So we can use the quotient rule. So let's go ahead and let's do everything. So we have the bottom function, which is cosine of x, times the derivative of the top. Well, the derivative of sine x is going to be cosine of x, minus the top function, which is sine x, times, we have the derivative of the bottom, and we know the derivative of cosine x is negative sine x. And this is all going to be over the bottom function squared, so cosine squared of x. Now again, this is the right answer, but we can simplify it. So this right here is going to turn into cosine squared of x. We have a sine x times a negative sine x. That's going to be a negative sine squared x on the inside of these parentheses. But we have minus a negative sine squared x, which turns into a positive sine squared of x. And all of that is going to be over cosine squared of x. I know what you're thinking, well, now we have all this mumbo jumbo and it doesn't equal secant squared of x. Well, don't forget your Pythagorean identity. Remember that sine squared x plus cosine squared of x is equal to 1. So in the numerator of this, we have a sine squared x plus a cosine squared. It's flipped around, but it's still equal because it's addition. And addition, it doesn't matter what order they're in. So this numerator is just going to be equal to 1. And the denominator is going to stay the same, so over cosine squared of x. And we remember from trig that 1 over cosine of x is always going to be secant of x. So if we have 1 over cosine squared of x, well, this right here is just equal to secant squared of x. Because secant is the inverse of cosine. So we see that using this quotient rule, we got what we memorized. We got the secant squared of x. So there is always going to be a way to solve these trig functions in terms of the quotient rule other than sine and cosine. Sine and cosine, you kind of just have to know. We solved those with graphs, which we haven't got into yet. But right here, we can use the quotient rule to find out tangent, cosecant, secant, and cosecant. We can use quotient rule for all of those. Let's go ahead and do another example here of the quotient rule. Let's try, we want to find the derivative of 1 over x squared. Okay, so we have a quotient here, so we can use the quotient rule. So let's do it. The bottom function right here is x squared, multiplied by the derivative of the top. Well, the derivative of 1, that's just a constant, so it's going to be 0. So this is 0, minus the top, which is 1, multiplied by the derivative of the bottom, which is going to be 2x, using the power rule. And all of this is going to be over x squared squared. So anything times 0 we know is going to be 0. So this whole thing goes away, turns to 0. Now we have minus 1 times 2x. Well, 1 times 2x is just going to be 2x. So on the top here, we're going to have a negative 2x over, if we multiply this out, so if we do x squared multiplied by x squared, we get x to the 4th. So there's x to the 4th on the bottom. One more thing we can do is we have an x that we can pull out. So we have an x here, and we can divide an x here. So this turns in, we cancel this one out, we have minus 1 here. This ends up being negative 2 over x cubed, because we cancel an x out of the numerator and denominator. That's our answer, negative 2 over x cubed. Now what I want to point out to you though, is this was a case where we could simplify this down and then use the power rule. Because from algebra, we know that if we have an x squared on the bottom, if we want to change that up to the top, we just have to make the exponent negative. So this is the same thing as x to the negative 2. Now I know we haven't worked with something like this yet, but this is still the same as a power rule, because remember our x to the n? This is an n. It doesn't have to be positive, it can be negative 2. So we can bring this negative 2 down to the front, and then we can multiply by x to the n minus 1. Remember the n minus 1? So negative 2 minus 1 is negative 3. And then remember we have a negative exponent on the top now, so we want to make that positive and bring it down to the bottom. So this is the same as negative 2 over x to the positive 3. We got the same answer. Now I know I do stuff like this a lot, where you can use the power rule instead, but it's really important that you know that, because a lot of the times you're going to be able to use the power rule and it just makes your life so much faster, so much easier. You need to understand that something like this, you can use the power rule for that, because you can change that exponent up to the top. Now a lot of these you're not going to be able to use the power rule for, because they're functions that can't actually be divided by each other, but this can. And so you can use the power rule for this. Now I'm going to end this video with a little bit of a harder example here, because we're going to combine two rules together. So let's say we want to find the derivative of 3x sine of x over e to the x. Now I know, that's nasty. Nobody wants to do that, right? But this is an example that you're probably going to get. So let's go ahead and solve that out. So we're going to do the quotient rule here. We're going to start over here so we can give some more space. So we have our bottom function, so that's going to be our e to the x, times the derivative of the top. So I know you're looking at this and you're thinking, well, what is the derivative of that? Well, you see we have a 3x and we have a sine of x, and they're together. So that means they're being multiplied. So what we have to do here is use the product rule to solve the derivative of the top. So let's go ahead and do that here. So we have the product rule. So we remember that that is the first term, so that's our 3x, times the derivative of the second term, which is cosine of x, plus the second term, which is sine x, times the derivative of the first term, which is 3. And if you don't remember that rule, I'll link to the video in the description. I'll also put a card up right now for the product rule video. But now we can go ahead and simplify this a little bit. So we have 3x cosine of x plus 3 sine of x. That's our derivative of this top part. So now we have to plug this back in right here. So let's do that. So we have 3x cosine of x plus 3 sine of x. And make sure when you're doing this, you have to put parentheses around that, because when you're multiplying the e to the x, if you don't put parentheses there, then you're just multiplying e to the x to this one. But the e to the x goes to the entire derivative. It's the bottom times the derivative of the top. So it's got to go to both. So now we're going to subtract. I'm going to go ahead and erase this so we have some more space. Now we're going to subtract the top term, which is our 3x sine of x. And we're going to multiply that by the derivative of the bottom term. So this is not supposed to be here. The derivative of this bottom term is going to just be e to the x. Remember that. Times e to the x. And all of this, never forget, all of this is over the bottom squared. So we have e to the x squared. Now this is really nasty, and I know it's really nasty, but we can simplify this. So what I'm going to do is I'm going to go ahead and distribute this e to the x to everything. So distribute e to the x here, distribute e to the x here, and here. So what we have here is we have, on the top, 3 e to the x, x cosine x, plus 3 e to the x, sine x, minus, well, when we distribute this out, we have 3 e to the x, x sine of x. And all of this is over. I'm going to show you what I'm doing here. e to the x squared, we know that this is the same thing as e to the x multiplied by e to the x. So I'm going to go ahead and do that. And you'll see why in just a second. Now what we can do with this is, and the reason I wrote it like this is kind of confusing, but I want to show you that there is a 3e to the x in every one of these terms. So you have a 3e to the x right here, a 3e to the x here, and a 3e to the x here. So we can factor that out of the equation. So what we're going to do is do 3e to the x on the outside. Then we have what's left on the inside. So we have x cosine x plus sine of x, right? And then we have minus x sine of x, all over e to the x times e to the x. Now there's one more thing we can do here. We have an e to the x in the top and we have two of them in the bottom, so we can go ahead and cancel these out. Cancel one of them out. So now we're left with 3 on the outside, x cosine x plus sine x minus x sine x all over, we have one e to the x left down here, so we're just going to put e to the x, and that right there is our answer. Now I know this question is kind of long-winded, and the reason it's so long is because we had to use the product rule in the quotient rule. Now a lot of times you're going to have to do that. You're going to have to use rules and rules. I mean, we use the power rule in these all the time. We did it here a bunch. We did it in the previous examples. The power rule shows up a lot. But when you have to do a rule as complicated as the product rule in a rule as complicated as the quotient rule, it does get long. But I can assure you this is the right answer. We did get there, and I hope that everything made sense. The one part that you do need to understand is there's a lot of times where you can factor something out of every term, so like we did with this 3e to the x, and you can cancel it with the bottom. So don't lose a point on your quiz or your test because you didn't factor and you didn't cancel stuff out, because a lot of times they want the simplified answer. This is as simple as it's going to get. So I want to give you practice doing the simplified answer so that you don't miss anything on a quiz or a test. But yeah, this is pretty much it for the quotient rule. There's a lot of like functions that I didn't use, like the natural log of x, square roots of x. All those things, they're applied the same way in the quotient rule. Just because I didn't use them doesn't mean they work any differently. So you can still use the quotient rule for all those. There's nothing special. It may get a little more complicated, but the quotient rule is not easy. I'm going to be honest. The quotient rule is one of the hardest derivative rules you'll use. So, but yeah, I hope that everything here made sense. If you do have any questions, let me know in the comments, and I will see you next time.